All right. So hopefully between the review, between the test, you're getting familiar with the way that they kind of do these things where we have the explicit functions, that's the calculus work, but then we have the problems where we're given the tables and the graphs, and those really come down to using the rules. So we have f of x, which is given in a table, and we've got these other functions which are built from f of x. We have to use the product rule on them. Honestly, the biggest thing as we go through C1 and then when we hit the chain rule in C3 is identifying what you have. If you have a product, you use the product rule. If you have a quotient, you use the quotient rule. It sounds silly, but it's things that we forget. When we're doing 7 other things later, I can't tell you how many people will just take this derivative thing by thing. They'll say, oh, the derivative of 4x is 4. The derivative of, I bet you this turned on. No, it's turned on. It's still on. Good. The derivative of 4 is 4. The derivative of f is f prime. They might remember to bring the 5 out, but they'll literally just write one thing, one term, instead of the 2 correct terms being added. Okay, so I'm going to practice these in the idea of not writing out my u's and v's, keeping track of that in my head if you need to write out the u's and v's until you're good at not doing it. But if h of x is a product, I know that h prime of x is equal to the derivative of the first, which is 4, times the second, which is the f of 5x, plus the same 2 things, but take the derivatives oppositely. Leave 4x alone and take the derivative of f of 5x. What's the derivative of f of 5x? 5 times f prime of fx. Yep. The linear chain rule feels tricky when you first see it, but I like to introduce it so early so that at some point we look for arguments. What's my argument? As soon as my argument has that linear coefficient, I have one more number to bring along. Notation-wise, when I write h prime of x, I should have x's. I'm pretty much now ready to find h prime of 1, so now I'm going to have numbers in them. Don't mix match this notation. If you say that h prime of x equals, and then you start plugging the 1's in, you've written bad notation. Thinking of things that I've seen. So we've got 4 times the f of 5 times 1, so f of 5, plus my 2 coefficients multiply together to give me 20. I have a 1 for my x, and I need to take the f prime of 5. Agreed? I combined the 4 and 5 together to give that 20. I showed the plugging of that specific x in just to make sure I don't miss it. And 5 times 1 is 5. Cool. All right. So for f of 5, now it's just a matter of going to the table. 4 times the f of 5 is 4 times 3, plus 20 times the f prime of 5, which is 7. We've got 12 plus 140, 152. Oh. Sound good? Yeah. Cool. All right. Letter B. We've got g of x. We've got sine of 2x, which feels, but we're going to plug 0 into it. So we're going to be plugging 0 into sine and 0 into cosine. Those should, at some point, be getting pretty close to automatic. Which one's going to give you 0 when you plug 0 into it, sine or cosine? Sine. And the other one's going to give you 1. Yeah. The quicker and better you are at that, you don't even need to think at the unit circle. You know, that's sort of the behind-the-scenes game that we're working on. Okay, so g prime of x, derivative of the first. So I'm going to start by finding the derivative of sine 2x, which is 2 cosine 2x. Yep. That's my reasoning for doing the linear chain rule so early. 2 cosine 2x times the regular second, so f of x, minus, because it's the quotient rule, leave the first alone, sine 2x, take the derivative of the second, f prime of x. Derivative of the first, and then everything else should go from there. Denominator is the f of x squared. Now we will take the g prime of 0. So we have 2 times the cosine of 0, which we said was 1, times the regular f of 0, which is negative 4. Minus sine of 0, we said was 0. F prime of 0 is something, but in the end, who cares? Because we're going to multiply it by 0. We've already found out that f of x was negative 4, so now our denominator is negative 4 squared. We've got a negative 8 over a positive 16. Yes? Positive 16? Negative 4? Okay, sorry. Yeah. So negative 1/2. Oh, that's what you said, negative 1/2. Gotcha. I heard the negative and I thought someone was correcting something that I had done wrong because I just assumed that's what's happening. Right. The more, I mean, this is its own style of problem. It's testing that you know the rule more than it is, the algebra piece of it. All right. Same deal on this one. Now we have a graph. If I want f prime of my graph, I love that this program doesn't give me any happy medium between 100 and 170. I couldn't possibly want any percentage between 100 and 179, right? What's that? I think I can do this. Yeah, look at that. Yep. Yeah. Sometimes moving ahead just, without taking the second to think about it gets you the results you would expect. Okay. Anytime we know your graphs, we have f and we have g. So if I need the values, I read the graph. If I need the derivatives, I read the slopes, correct. If any of these, and I can't remember if I may have done this on purpose, if any of these come up does not exist, we are going to have a slight issue. So we will take a look at those. I didn't do these ones. So let's start with h prime of negative. Actually, do you guys want to try these?
Yeah.
Sure. Yeah. Yeah. I mean, I feel like these are ones we should try. Totally try.
Let's do it.
All right. Okay, so after the students worked on those problems, these are the answers that we came up with. We did not go over them, so I just wrote them on the board. So if you're watching the video, you'll have them. The reason we skipped h prime of 6 is that you would find at h prime of 6 that you are not differentiable, which means that your left limit, of the derivative, would not equal the right limit. They would be negative 1 coming in from the left and positive 1/2 coming from the right. And because the only way that would actually give you a result would be if this value were 0, because the left limit would end up being multiplied by the right limit, or the left limit and the right limit would both be multiplying by 0. But because they were being multiplied by 1, finding the left derivative and the right derivative would give you different results. I don't think that's something that I'm looking to put on an assessment, and I don't think that's something that the AP test is really looking to do either. So basically, you would actually have a left product rule and a right product rule, and they'd give you different results, which would tell you overall that limit does not exist. And again, the way you know that they're giving you different results is in the left one, you'd be multiplying, when it came time to multiply g prime by f, you'd be doing negative 1 times 1. When it came time to do g prime times f, doing the right limit, you'd be getting positive 1/2 times 1. So you would be getting different results for the product rule for both. That's why that does not exist. That's what's going on there. So that is everything with the product and quotient rules. And we will stop there.